Well, that's a nice story and all, but what does that have to do with our exothermic reaction and the chart it makes? Well, let's start at the beginning. Here we have our kids studying. Their potential energy is very high because they can party and they have a lot of potential, but low kinetic energy because they're not doing anything. In order for that to change, they have to go through a reaction. In order for a reaction to happen, you have to have an activation energy in the form of a spark. That spark is the boombox, which starts the party. As the kids start studying and start partying, their potential energy rises and then lowers because they get tired. As the party continues, they get more kinetic energy, but less potential energy as they get more tired. Once the party's over, they have low potential energy, but high kinetic energy. Their reaction, heat of reaction, is going to be negative because you get your heat of reaction from minusing the potential energy of the products minus the potential energy of the reactants. And so, since you have less potential energy of the products, and you have more potential energy reactions, it means your reaction is going to be negative in the form of losing heat.
Somewhere in Canada, there were 3 toddlers, James, Bowen, and Alex. The 3 went to the same Canadian daycare when something happened that would change their potential energy forever. Not really, only for a couple of minutes.
I'm bored. I'm tired of making rocks at the playground. We'll make something else.
Yeah, what he said.
I can't make something else. I'm tired. We should go have some blankets and grab some warm milk and go to sleep.
That sounds great.
Yeah, good idea. Let's go.
The toddlers are about to have their potential energy increase. Their activation energy is the warm milk and the blankie, and it will cause them to fall asleep and have their potential energy at its peak, or at its activated complex. Let us see what will happen next. The toddlers drink warm milk and grab their blankies. The toddlers instantly fall asleep. Aren't they so cute while they sleep? Look, they are asleep. They have reached the peak of potential energy since they, while they sleep, are gaining energy. Let's find out what happens when they wake up.
6.5 hours later.
The 3 toddlers awaken.
That felt great. I feel so energetic and ready to take on the rest of the day.
There are only 20 minutes left before we go home. Whatever, let's enjoy the rest of our 20 minutes playing tag!
The 3 toddlers have entered a higher potential energy state than from which they started. This is called an endothermic reaction. So today you have learned about how potential energy works. But now I need a nap. Au revoir, adios, goodbye.
Those babies were so cute, and their actions can teach us a lot about how potential energy diagrams work. The babies' actions demonstrate an endothermic reaction. The babies were bored playing with Play-Doh and were becoming tired as well. This demonstrates how they had a low potential energy. All the babies needed was a spark, or some sort of activation energy, to get the reaction started, and this came in the form of blankets and warm milk. The blankets and warm milk triggered the reaction, which were the babies sleeping. As they slept, the babies absorbed energy, and when they woke up, they were ready to play. This shows how they now had a high potential energy. As they played, they released some energy in the 20 minutes they had left in their play date, but they did not release so much energy that they still had more energy than what they started with before their nap. Since they ended up with more potential energy than they started with, so the low potential energy, they demonstrated a typical endothermic reaction.
Alright, this is baby scene, take 856.